Now, in the last unit, we talked about special angles. We were only talking about them in degree measure. So now let's look at what those angles would be in radian measure. So for each one of these special angles, we're going to look at the exact radian measure and then an approximate radian measure. If we have 0 degrees, that's the same as 0 radians. If we have 30 degrees, if we convert that to radians, then we're multiplying by pi over 180 degrees. That's going to simplify to pi over 6. So this is the same as pi over 6 in radians. And here's the approximate value of that in radians. Then let's look at 45 degrees. If we convert that to radians, 45 over 180 turns out to be 1/4. So this is the same as pi over 4. And to do the approximate value for that, it's best to use that pi key on your calculator for something like this so that you get as little rounding error as possible. If we do that on the calculator and round this to 2 decimal places, it would be approximately 0.79. Here's one that's given in radians, and we want to see what the degree measure of that one would be. So for pi over 3, to convert this to degrees, we're multiplying by 180 over pi. The pi's cancel out, and we end up with 180 degrees over 3. That would give us 60 degrees. So this is 60 degrees. Then we could also do the approximate radian measure. That turns out to be 1.05. For 90 degrees, if we convert that to radians, we end up with 90 pi over 180. You can cancel out 90, and this ends up being the same as pi over 2. And an approximate value for that one would be 1.57. This one down here, an approximate value of 3.14, well, that's an approximation for pi. And then pi in degrees, this was the one that we were using for our conversion fractions, so that's the same as 180 degrees. If we have 3 pi over 2 in radians, when we convert that to degrees, our pi's cancel out, and then we would take 3 times 180 degrees over 2. That ends up being 270 degrees. And a decimal approximation for 3 pi over 2 would be 4.71. Last of all, for 360 degrees, we already talked about the fact that this is the same as 2 pi radians. A decimal approximation for that would be 6.28. It's going to be important to know these values. These are all first quadrant special angles that we talked about, and we're going to do the same things with these that we did with degree measure. So it's pretty important to know that 30 degrees and pi over 6 are the same. 45 is the same as pi over 4. 60 degrees is the same as pi over 3. And then these over here are the quadrantal angles. So 90 degrees is the same as pi over 2. 180 is the same as pi. 270 is the same as 3 pi over 2. And 360 degrees is the same as 2 pi. Let's just look at a circle. This has those special angles that we already talked about in the first quadrant, and it has the quadrantal angles on here, except it doesn't have this one. 360 degrees is the same as 2 pi. Then it also has some of our other special angles in the other quadrants. Remember before we talked about reference angles? So each of these angles here has a reference angle in the first quadrant. We're also going to talk about reference angles in radian measure. So one thing to think about with these quadrantal angles is we're going to be dealing with fractions. So if you think about pi over 2, if you think about that as a fraction, that's the same as 2 pi over 4. It's also the same as 3 pi over 6. Pi would be the same as 6 pi over 6, would be the same as 4 pi over 4, would also be the same as 3 pi over 3. So for example, if we wanted to come all the way around to pi radians and then back up by pi over 6, then we'd be thinking of the pi as 6 pi over 6, and if we subtract pi over 6, that would get us back to 5 pi over 6. 270 degrees is the same as 3 pi over 2. 3 pi over 2 would be the same as 9 pi over 6, or the same as 6 pi over 4. And then last of all, if we look at 2 pi, that's the same as 12 pi over 6, which is the same as 8 pi over 4, which is the same as 6 pi over 3. All of these, if you simplify them, you get 2 pi. That's just something that's going to help you when you're trying to deal with these radian measures if you think about these quadrantal angles with different denominators for the fractions. So let's find some function values where we have the angles in radian measure instead of degree measure. So we're going to go back to this circle and try to find where these angles are to start with, and then use some of our facts from the last unit to get our function values. So if we're looking for the tangent of 9 pi over 4, first we would want to figure out where 9 pi over 4 would be on that circle. So let's just take the fraction part of this, the 9/4, and we can think of that as a mixed fraction. If we think of that as a mixed fraction, that would be the same as 2 1/4. So if we put the pi back in here, this would be the same as 2 pi plus 1/4 pi, or in other words, 2 pi plus pi over 4. 2 pi is the same as 360 degrees. If we're looking for a coterminal angle with this, then we could just knock off the 2 pi, and our coterminal angle would be pi over 4. So 9 pi over 4 and pi over 4 are coterminal. That means that the value for tangent for these two angles is the same. So now we want to see what pi over 4 is, and let's go back to degrees. So if we go back to our circle up here, pi over 4 is the same as 45 degrees. So the tangent of 9 pi over 4 is the same as the tangent of pi over 4. That's the same as the tangent of 45 degrees. And remember, for tangent, we can use sine over cosine. These two values for 45 degrees were both the same. They're both the square root of 2 over 2. And that means that our tangent value for this angle is 1. So the tangent of 9 pi over 4 is actually just equal to 1. Let's look at the sine of 3 pi over 2. Now this one's a little bit easier because this one is already on our circle. So 3 pi over 2 up here is equal to 270 degrees. And if we even look at where this is on the circle, this is a quadrantal angle. We could think about an x and a y and an r. So for example, if we made this point 0, -1, then our y is -1 and our r would be 1. So the sine of 3 pi over 2 is going to be the same as the sine of 270 degrees, which is -1. For this last one, we're looking at a negative angle, so we're going to have to go back in this direction. We can also think about what angle would be coterminal for this one, but positive. To find a coterminal angle, if we had this in degree measure, we would add 360 degrees, but since it's in radian measure, we're going to add 2 pi radians. Now here's where you can think about the fraction part, and you can even do the fraction part with your calculator if you want to. So if you just think about -4/3 plus 2 and leave out the pi, you can take that and turn it back to a fraction, and that gives you 2/3, which means that this would be the same as 2 pi over 3. Our coterminal angle is 2 pi over 3. If we look at where that is on our circle up here, that's up here at 120 degrees. This is not in the first quadrant, so we'd have to think of a reference angle. Our reference angle for this would be 60 degrees. The cosine of 60 degrees is 1/2. Since our actual angle was in the second quadrant, cosine is negative there. So the cosine of our negative 4 pi over 3 would actually be equal to negative 1/2. Now this seems kind of complicated where we keep changing things back to degrees. That's another reason to get used to dealing with the angle measures in radians. So if you can go back to this circle and kind of get the hang of what these special angles are just in radians, then you won't always have to be converting back to degrees.